Now we are going to see about first come first serve algorithm. First come first serve algorithm is a non-preemptive algorithm. Non-preemptive algorithm means, suppose we are having two processes, say P1 and P2. That is, after the completion of P1 only, this P2 have to execute. While P1 is executing, another process cannot interrupt its execution. அதாவது P1 ஒரு process execution start பண்ண ஆரம்பிச்சிட்டுனா அது complete ஆனதுக்கு அப்புறம் தான் next process execute ஆகணும். That is non-preemptive algorithm. The problem based on this algorithm will be like this. That is, in the question, the set of process with arrival time and CPU burst time in millisecond will be given like this. And we have to draw Gantt chart and calculate the average waiting time and turnaround time. Like this question will be given, and a table showing the different process and its arrival time, and BT is the burst time, will be given like this. Okay. So for this we have to draw Gantt chart. So this algorithm is first come first serve algorithm. Here the process which arrives first will be executed first. Okay. See, so in this process we'll be checking with the arrival time. See which process has minimum arrival time. In this problem, the process P1 has arrival time 0 millisecond. Okay. So the first arrived process is P1. So the Gantt chart, P1 is the first process. So BT is the execution time of that process in CPU. So P1 process arrives at 0 millisecond and it executes up to 4 millisecond. So 0 plus 4 millisecond. So up to 4 millisecond P1 process executes. So after the process P1, process P2 arrives. How we are saying means, see, the minimum arrival time is 0. After that 1. This 1 belongs to process P2. So P2 is the next come process. So P2 has execution time, that is burst time, as 3 millisecond. So already here we are having 4 millisecond. So plus 3 millisecond means 7. Okay, next process with the minimum arrival time is P3, that is with 2 millisecond. So the process P3 will be executing. See, what is the execution time of process P3? It is 1 millisecond. So 7 plus 1 millisecond, 8. Okay, next, the minimum arrival time is for process P4, that is 3 millisecond. Then process P4 will be executed. See, the execution time, that is the burst time of the process P4 is 2 millisecond. So 8 plus 2, 10 millisecond. Next, the last process which arrived in the system is P5. So P5 has burst time, that is the execution time as 5 millisecond. So P5 will be executing from 10 plus another 5 millisecond. That is up to 15 millisecond. Okay, this is the Gantt chart. Here we have to calculate the average waiting time and average turnaround time. For this, before calculating the average waiting time and turnaround time, we need to calculate completion time. It is given as CT. So CT is nothing but the completion time. So what do you mean by completion time? Completion time is the time at which the process execution gets completed. If you see, we are having the first process, say P1. See, P1 gets completed at 4th millisecond. So the completion time for P1 is 4 millisecond. Next, the completion. This we have to see by means of Gantt chart. Next, the completion time of process P2 is 7th millisecond, the process P2 gets completed. So here 7. Next P3 gets completed at 8th millisecond. So 8. Then P4 gets completed at 10th millisecond. So 10 millisecond. Then P5 gets completed at 15th millisecond. So 15. Likewise, we have computed the completion time. Next, we are going to calculate turnaround time. So what do you mean by turnaround time? Turnaround time is the time between the process arriving the system till the process gets completed. Okay? Can also be calculated by using the formula turnaround time is equal to CT, that is completion time minus arrival time. So turnaround time, so 4 minus 0, 4. So 7 minus 1, 6. So here 8 minus 2, 6. Here 10 minus 3, 7. Here for process P5, 15 minus 4, 11. Like this, we have computed the turnaround time. Next, we have to calculate waiting time. WT is your waiting time. So what do you mean by waiting time? So waiting time is the time how long the process has waited in the system for getting its execution to be completed. See here, process P1 arrives the system at 0th millisecond and it also starts its execution at 0th millisecond and it has completed its execution. So this process P1 doesn't wait at all. So the waiting time of process P1 is 0 because this process P1 arrived at 0th millisecond and it starts its execution and gets completed its execution at 0th millisecond itself. That is from 0 to 4 itself, it completed its execution. Next, process P2. See, process P2 arrived the system at 1st millisecond, but it started its execution at 4th millisecond and gets completed at 7th millisecond. So this process P2 waited from 1st millisecond to 4th millisecond. So 1 to 4 millisecond it had waited means 4 minus 1. That is the waiting time for the process P2. That is 3 millisecond. Okay. Next, for the process P3, the process P3 has arrived the system at 2nd millisecond, but it started its execution at 7th millisecond. Okay. So this process P3 has waited in the system from 2 to 7 millisecond. That is up to 5 millisecond. This process waited. That is 7 minus 2, 5 millisecond. Next process P4. P4 arrives the system at 3rd millisecond, but P4 started its execution at 8th millisecond. So the process has waited up to 3 millisecond to 8 millisecond. That is 8 minus 3, 5 millisecond. Then the last process P5 arrived the system at 4th millisecond. This P5 started its execution at 10th millisecond. So it has waited from 4th millisecond to 10th millisecond. That is 10 minus 4 is 6. Next, we can calculate one more thing, that is response time. So in case of non-preemptive scheduling algorithm, waiting time and response time are same. So we can simply copy the response time as the waiting time. Next, we have to compute the average turnaround time. So how will you compute the average turnaround time? That is, here we are having average turnaround time. So for 5 different processes. So the first process 4 plus 6 plus 4 plus 6 plus 6 plus 7 plus 11 divided by 5. That is 34 by 5, which is equal to 6.8 millisecond. Okay. Next, we have to calculate the average waiting time. Here the waiting time 0, 3, 5, 5, 6. So you have to add all these and divide it by 5. That's how you will be calculating the average. 0 plus 3 plus 5 plus 5 plus 6 divided by 5, which is 19 by 5, is equal to 3.8 millisecond.